All right. So this week we're going to be working on aggregation. And aggregation is really I think it's one of my favorite things about SQL because it's so reporting heavy, meaning we do it when we want to report things. And there's just really a lot of really fun things you can do with it. So anyways, this is one of my favorite weeks. I think it's just fun because we can join data and that kind of stuff, but really using the data is, I think, where we're really starting to dive into in this week in particular. So anyways, what I thought we'd do is we could just work through some of these exercises and just kind of talk about it along the way. So I'm just going to preview this exercise so we can kind of just go through it. So question number one, and I guess let's just start with question number one. So question number one says construct a query that counts the number of rows in the payment table. So, as with, and I guess while I'm making sure that my database is on, as we're kind of going, remember that aggregation is really a function of making sure that we're compiling records down. So we're taking many records and kind of rolling them down into a single record. And that's why they call it aggregation. We're taking many things and summarizing them. And so what we're going to do, and there's lots of different functions we can use, is kind of what's up here: max, min, average, sum, and count, to name kind of the common ones. So in this case, we just wanted to count the number of rows. Now, one of the things that we do often is count just the number of rows to make sure that it's we're seeing the results that we want to see, essentially. So we may count from a table just to say oh, how many records are in this table. So for example, select the count of everything from, let's just say payment, since that's what we're kind of looking at here. So the count of everything from payment, and we can kind of take a look at our results, and you'll notice instead of returning many rows, we've summarized it down to one, and there's 16,044 of those records. So in this case, it says construct a query that counts the number of rows in the payment table. Well, we just did that. So that's as simple as that. Doing one is really easy because we can just basically summarize everything in the whole table. Just for additional context, we could do the same thing, but let's say instead of count, we want to sum the amount of payment, or sum the amount that's paid from all the payments, basically total revenue of our business, and so we can see that we did 67,406 revenue in total since at least we've been collecting the data, which hopefully is when we kind of started running. All right, so question two, it says modify your query from the first exercise to count the number of payments made by each customer. And it says show the customer ID and the total amount paid for each customer. So this is where we're going to start getting into more of what makes aggregation just a little bit more complicated at first glance, but hopefully we can break it down and make it pretty easy. So anyways, we have our amount here. Let's go back to where we were counting the number of rows. And let's see, what did it want to say? Yep, count the number of payments made by each customer. So same kind of metric, but we just want to add a segment. We want to see, okay, here's how many total payments there are, but now we want to see that divided how many each customer had. Essentially, we want to group the number of payments made by each customer. So that's essentially what we're going to do. So we're going to add the customer ID here. And then we have our count, which will stay the same. Now, if I run this, by default, you'll notice that it throws an error. It says, hey, you have an aggregated query without a group by clause. And it says, this customer ID is here, but I don't know what to do with it. So essentially what we have to do is we have to just say, hey, I'm summing up some stuff. I want you to group it by the customer ID. Now, as a shortcut, pretty much whenever we do aggregation with some other parameter, or value, we have to choose, we basically have to include it in the group by clause. So the shorter answer is if it comes up here and it's not aggregated, then we want to include it in the group by clause. So when we run it this time, you can see that now we get the customer ID and the count for each one. So this is the solution for number 2. Now,
so on a non-aggregated function, if you took away that count, you could do count distinct and get rid of group by, right? But as soon as you put that count distinct in, will it let you run that with the count? So on this one here, you could do count select distinct, right?
Basically, it would be the same thing.
Does it let you do it if you do select distinct and then I think that will run the IDs, right? And then if you do the count, does it let you do it without the group by?
So it shouldn't, because count distinct is just going to remove any duplicate of these rows. So now if I take out the group by, it still is going to throw the error because it doesn't quite know what to do with this.
Yeah, it doesn't know to do it on the non-aggregate functions.
Oh yes, exactly. Because basically what the distinct does, it just removes the any duplicate rows across all the entirety of the data.
Okay.
Yeah. So, but now we can do a count distinct, which is a little bit different, meaning it counts unique values of whatever it is we're doing. In this case, because we're counting payments, it's one and the same. But I usually, just for the sake of being sure, I usually go like this. Count distinct payment ID. That's total payments. But anyways, want to take this like one step further to kind of show you, like, because once we have like our common dimensions, which is pretty common like nomenclature in like the BI world, we have the things that we want kind of to group the data by, and those are dimensions, and then we have the things that we're aggregating or summarizing, and those are the metrics. So in this case, customer ID is the dimension, and the count of total payments is the metric. And once we kind of define the dimension, we can, which is in the group by clause, we can add as many metrics as we would like. So for example, I could also do the sum of amount as total spent. And then we could also, take that one step further to say, hey, what is the average spend for each user? So, or, per payment, how much do they spend per payment? So we can take the sum of amount and divide that by the total number of payments and call that amount per payment. And now we can kind of see, like, essentially who's the biggest spender. So, because now we have like a total number of metrics. We can see, how many total payments did they have? What was the total spent, and what was their kind of like average amount per payment, essentially. So once we define this common dimension using the group by clause, we can add as many metrics as we would like. All right, so there's that one. Oh yeah, so count the total number of payments made, show the customer ID and the total amount paid for each customer. So we're one step ahead there. All right, so now we're going to take this to the next level and say, okay, we've aggregated all this, and now we want to filter. Now, what's interesting, so this says modify your query to include only those customers who have at least 40 payments. Now, we're used to filtering by using the where clause, and you'll notice that I don't have a where clause here. But the problem is if we remember the order of operations, and this is why I kind of cover that, first thing, is if we think about the order of operations, basically what's going to happen is it's going to run the from clause to get the data, and then it's going to run the where clause to filter anything out. The problem is, so like if I said, oh, I want it only where the total payments is greater than or equal to 40, the problem is this metric doesn't exist yet, total payments. In fact, if I run this, it's going to throw an error because it says unknown column total payments. So because at this point, when it hits the where clause, it has no idea of the aggregation because it first runs the from clause, then the where clause, then the group by clause. So the where clause is for filtering out any data pre-aggregation. So what we do is instead of using the where clause, we use the having clause, because the having clause comes immediately after the group by clause. So we can say having total payments, and let me just make sure we're right here, who have at least 40 payments. Yep. So greater than or equal to is the correct kind of metric there. And so having, we could have a where clause and a having clause, but the having is a filter for aggregated columns. So just know that the group by and the having go together, and that the having is basically the where clause for aggregation. So now if we run this, you'll see that we actually get returns, and we can see those customers who have at least 40 total payments.
Can you switch the position of group by and having? Does it still work, or does it break it?
It will break it. And that is because, well, one, just syntax, and two, again, order of operations. First it has to gather the data, then it has to essentially aggregate it, which happens really at this step. This group by clause is really how it determines, hey, this is how I lump this all together, and then only then can it filter it. Because if it essentially, if it doesn't have the total payments by customer, it can't filter out the ones that it hasn't added yet, essentially.
And this could be from my memory from Python, but is not having, like is having and is not having, or is that just having and you're just doing not equals to 40 would be is not having?
Yes, yep, exactly. So just like the where clause, we just put like having, and then we put any conditional there. So just like the where clause, we can say, having payments greater than or equal to that, or amount per payment greater than or equal to 5, for example. And so we can, we can kind of do one or the other, essentially. So once we have the having clause, it's any conditional, just like the where clause.
Hey, can I interrupt for a second?
Yep.
I'm in the middle of making dinner, so I might have missed when you were talking about this. I got you on the kitchen counter. But I submitted this assignment already, but I did not do the sum divided by the count distinct payment ID when I submitted it. I'm trying to think what I did. I got my people, all of my customers, and then I figured out how many payment IDs went to each customer, because you've got like so many payment IDs with the customer. And then I figured out the distinct ones of that, but I didn't do any division. And I just, how many of them had, how many does each customer have? I've got their payment IDs, and how many of them have more than 40? And like when I played around with it, it looked like I got it right. But is this division portion essential to getting the correct answer?
No, no, yeah, this is just extra that I did.
Okay, because I'm like, if so, like I thought I understood it and I played around with it a lot, and I'm like, yeah, this is it. And then I saw your division, I'm like, oh, I didn't do that.
Well, yeah, no, this is just me having fun, because
okay.
I don't know, like I this is what I pretty much do all day, every day. And so I guess just like it bothers me that, because we can see the total number of payments and the total spent. But what that doesn't show is like, like if we're trying to evaluate, like if I was looking at this data from a business perspective, and let's say we're just like trying to highlight like, oh, who are our best customers?
Yes.
There would be essentially like two big metrics I'd want to look at, and that's the amount per customer and basically, you know, how long their tenure that they've been a customer. And then like I would probably even want to like, you know, and then like obviously like the total payments. You know, basically how long they've been a customer. You know, another metric would be like, you know, what's the cadence between payments essentially. But it really bothers me not to have this amount per payment. And I kind of throw it in just to kind of show that you can do arithmetic with the aggregations.
Yeah, and that is definitely, I'll say that it's definitely fun once you kind of figure it out and you're kind of like, ooh, I bet you I could figure this out too. And you know, you can just start playing around with it. That is a lot of fun.
Yep. And that's where I'd say like if you enjoy this part of it, I would say you tend to be more like on the analytical side of the data industry. If you don't care as much about this and you're more interested in like the schema and you know, that you're probably tending to be a little bit more on like the technical, the kind of like data engineering side. So just like as you're doing this, if you're like trying to decide what you want to do in life and you kind of find yourself leaning one way or the other, that's a good indicator. Like, oh, should I be more interested in like the stats analysis part or more like data architect engineer side? It's a good indicator.
Is there built-in functions for like standard deviation and just other statistical functions?
Yeah, there are. There's a lot. Standard deviation is hit and miss. And we'll actually, so as soon as we get through these exercises, I'll show you a lot more that we can do that I think will actually blow your mind just a little bit. So we'll circle back to that question.
Sounds good.
So anyways, customers with at least 40 payments. Oh, and that's actually it. So I guess there's only 3 this week. So nice and easy as far as the exercises go this week. So anyways, I want to preface this to say, like, as far as like what we've just now covered, that is largely like where we should be for this week. So what I'm about to show you is definitely stretching just a little bit. So I want to preface that so that way if you get lost, confused, that's okay, because like we're gonna stretch here. So if you feel comfortable now, great. Like you should be. You know, if you can make it through those exercises, like, and it makes sense, then we're good. But what I'd like to do is show you kind of like some additional stuff that the reason why I like to cover is because one, it's always nice to know that it exists, even if you don't know how, so that way you can like Google it and, you know, figure out how to do it later. Because this is something that I honestly didn't know how to do until way further along than I thought I should have. So anyways, it just never came across my radar, which is surprising. So I always like to kind of get it out there. So anyways, like I'm just gonna kind of like build on this query we have. So we can kind of see like, oh, you know, by customer, what is the total that they spent essentially, and the amount per payment and all that. Now, one thing that we might want to see is like, okay, you know, here's our customers, the total they spent. You know, we could sort this and say, you know, oh, order by, I guess we can just say total spent ascending, right? So we can kind of like find like our best customers. Total spent, not spend. There we go. And I'm going to take out this having clause too, so we just get like the full KMA here. So there we go. So we have all this data here. So now what I want to do is I'm going to introduce you to something that's called a window function. You know, I don't think I've ever tried this on my SQL, so let's hope it works. I believe it does. But these are called window functions, and basically what we're going to do, so to raise a scenario, let's say I wanted to know, okay, here's how much this customer spent, right? Like our top customer, 526, spent $221 with us over his total lifetime. Now, what if we wanted to say, okay, but what is the, you know, that's great. What's the percent of the total? Like what percent of, you know, of the total revenue is $221? So what we're going to do is we're going to use what's called a window function to essentially do that. Because if we were just to add we're already aggregating by customer ID, but we want to not only aggregate by customer ID, but for this one little calculation, do the whole thing. So the first thing I'm going to do is just show the total sum. So I'm going to take the sum of amount and I'm going to say over, and I'm just going to put empty parentheses. So just over. And I'm going to say as total, we already have total spent. So I'm going to do, instead of total spent, I'm going to say
grand total or something.
Yeah, let's do grand total. That sounds great. Let's do grand total. So the sum amount over grand total, and you don't have it. Is it expression 4 of the select list?
You have to do partition by or no?
Yeah, so if we were going to partition it, we would. But in this case, we just want it over the whole amount. But I think what we got to do, sum over. We got this. There we go. Okay. So we sum, and this is the one weird thing about MySQL. So we have to sum the sum. So we take the sum of amount, which is basically our total spent, and we take that and we sum it. And this is the window function part over everything. So you can see here that we take the sum of this over all of the records, essentially, is what we're saying. So when we say over, say, hey, for everything I have here, take the sum of the amount and sum that for a grand total. So you can see that this is the same across all of the records, which is great. That's exactly what we wanted. So then from here, if we wanted to say like, oh, what percent it is this, we could say, okay, yep, we want to take the sum of amount over. But what we want to do is we want to take our first amount divided by it. And we'll call that like percent of total. And just to make sure that things are, I'm a little OCD about how things read. So let's do that. And, oh, and we forgot one thing. Let's just put another set of parentheses around here and multiply that by 100. There we go. So now we can kind of see the percent of the total. So, this individual makes up 0.32. So, basically what that means is, we have a lot of distribution of revenue, which is great. We don't have all of our eggs in one customer, essentially, which is good. So anyways, we could verify that by taking the 221 divided by 67,000, and it should get us there. But anyways, that's called a window function. Just to show you one more, so I'm just going to erase this for clarity here. So we did that one. Another way we can kind of do this is we can rank certain things. So let's say we just wanted to rank the amount that they spent, right? So we're going to do the same thing, but this time I'm going to say rank over, and I'm going to say order by the sum amount sending. And let's see, maybe it doesn't like, let's see what MySQL's rank function looks like. There's a dense rank, and then there's a, let's see here. Oh, that's right. We don't need to, that's right. So on this, we don't need to put anything in here because it just assumes it based on the over. So we say rank over. We basically choose how we want to rank it. In this case, hey, take the sum of their total spend, rank it descending, just like we already have here, and assign it a rank. And you can see that it should just go straight down here. I don't know if we have any with the same spend. Oh, look, we do. So these two customers spent the same amount. You'll notice they both get 27. So if we wanted to say, hey, don't do that, which in this case we probably would, right? Because they're the same. But let's say we just, luck of the draw, you came first. Here we go. So now this should, well, nope, it's still there. Amount rank, dense.
No, that's 27. It was 27, so it's not. There's 27, 28.
Yeah, but there's the
Oh, but there is some 37.
yeah. So let's see. Rank functions.
Yeah, I think the dense is non-repeating.
Let's see. I'd rather not. Huh. Okay. Well, I thought for sure dense rank was not supposed to be repeating. Assigned, basically the ranks are assigned in a consecutive manner. Oh, they will be assigned. Anyways, we can make that. They both apparently assign the same, which is interesting. Cool. So anyways, there's that. You can do ranks. And then I don't know if MySQL supports it.
Well, I think on that one, it did 37, 37, 38, whereas you do it the other way, what did it 37, 37, 39?
Yeah.
You know what I mean? So that's the difference between them. Is it whether it just picks the next numerical one or skips it?
Yep. Got it. That makes sense. And then to circle back to your question, so we have that rank. But what I'm going to do now is I'm actually just going to take I'm actually going to take the group by off. And what we're going to do is we're going to say total payments, total amount spent, amount per payment. And we're going to say, okay, what is our deviation on the amount? So we can go standard deviation. Amount. So we can see our standard deviation amount. So, basically not a lot. A lot of people spent about the same on average. Between gaps. But like I said, our data is very distributed. So, basically each kind of like chunk of person goes down about $2. So a nice little curve there, a very linear curve, essentially. But yeah, so lots of different functions. There was one more thing I was going to show you. Let me back this back, actually. And let's just keep it pretty standard. So I'm just going to have the total payments and the amount spent. So in MySQL, there's this option to do what's called a rollup. Let me see if there's any, instead of customer ID, let's actually do this by the year of payment date. There we go. We have now, instead of grouping it by customer, we're grouping it by, the year. And what we can do is we can add this with roll-up option. And what you'll notice is that we can, let's do order by payment year sending. So what this does is it has our year payments, right? 2006, 2005, we're descending. I guess let's put it ascending. There we go. We have 2005, 2006, but then it adds, if we do this with roll-up option, you'll notice that it rolls up that to kind of like a total row, essentially, because you'll notice wherever it's null, that's like the total. And in this case, it just sums it up. So
If you did customer ID in there, does it also do cube?
can you say that again?
If you have another element in there like customer ID, does it also do cube function as well as roll up? I know some versions also do cube instead of just roll up.
I'm not familiar with the cube.
Oh, you're not? Oh, yeah, it goes one more level even.
Yeah, and I know like we can add, like, for example, the month of payment date. Month. Oh, and I guess I need to add it here. And it should roll up all of them. So essentially we end up with like, both dimensions. So let me do payment year, payment month. I don't really like it because it gets a little weird, but essentially, we have our total, grand total, which both are null. We have our total for 2005, and then we have our total for 2006. Now we can see the month breakdown. So the with roll up will roll up everything, essentially.
If you switch roll up to cube, then it also goes by different combination. I think that's the syntax. Unless it doesn't support it.
Yeah, it doesn't
Or it
seem
might just be cube instead of with cube. I don't remember the syntax, but
let's try it.
yeah.
It doesn't take it too much.
Yeah, essentially what it does is instead of it does all possible combinations on the cube. So it's 3-dimensional instead of 2-dimensional.
Got it. And I know there's ways you can like essentially pull things up into like a pivot, but that gets really complicated with just SQL.
Yeah.
But anyways, like I said, like the window functions and that is kind of just like bonus. So anyways, that's actually all I had. Does anyone have any like questions about aggregation? And I guess just before we go, does the concept of aggregation make sense, essentially? Anyone have any concerns? All right.
I'm good with it. If you want to try that cube thing, do cube and in front of your after your group by write the word cube and then put your stuff in parentheses.
Cube.
And then put the whatever you want to cube it in parentheses. And that should change the answer into more detail. That still didn't work. That's what it says.
Let's see here.
Yeah, roll up cube. Yeah, that's you play it'll make your head spin.
Yeah, interesting. There's the roll up, which we've done. Time, region, department. Yeah, that should work.
Yeah, on that data set, when you scroll down, it said like the null was in the middle there. Like 1996 East or 1996 East, and then a null for the department. So it just starts putting those nulls in different positions. So you get every different variation.
Yeah, interesting. Interesting. Yeah, and it could be that I just don't have the right. Well,
It
let's see.
might not, it's a free version, right? So that might
Yeah,
not do it.
that
I bet
kinda-
on your work one, it would do it.
Yeah. Q is not. Yeah, it looks like it just doesn't like it. So yeah, I wouldn't be surprised if that's the case. But just like I guess for clarity, it looks like what the difference is so like cube may not actually be the best answer just for this scenario because I have like the the month and the year kind of like built in there. But like if we were looking at like product like revenue by different categories, like let's say we were looking at our video store rental by category of film, like sci-fi, fantasy, that, and also by rating. The cube I think would definitely be the better solution.
Yeah.
All right. Well, if there's no other questions, I think that's all I had for this. So if you need anything throughout the week, let me know. The exercise this week should be pretty easy. At least for those of you here, you seem to grasp the aggregation fairly slick. So the quiz shouldn't be too bad either. But if anything comes up, let me know. Otherwise, I hope you guys have a great week.